Okay. So we continue with our discussion of functions. Now, I want to discuss some specialized inbuilt functions, right? And these inbuilt functions, they are a group of functions that you can use to manipulate objects in a data frame, matrix, and then a list. Okay, they also serve as a looping statements, right? Or in our we call something loops. Okay, so sometimes you have to work on a certain data and you have to go round, like you take this, you compute something, you take another one, you compute, and so forth. So when we finish with this, I'll briefly discuss, let's say, conditional statements and loops, and there you will see that you can still use this set of functions we are going to discuss on to perform looping. Okay. Now, so what are these functions? Okay. So these are the special function we want to talk about are the apply. We call them the apply family of functions. Apply family of functions. Now, what are these functions? There are several of them. Okay. So A, we can talk about apply. That's the basic one. B, there is S apply. Function. C, we can have L apply. A whole lot of them. Okay. D, there is also T apply. And I can go on and on. There are even parallel version of it. I mean, what does it do? So, for example, when you are doing, you have to work on so many things. You see, if let's say you have several data sets that are organized in lists, of course, we can use, for example, the L apply to do it. But if you are doing this in millions, or let's say you have a billion set of data, then L apply is going to take its time to go through 1, 2, 3, up to a billion. So you can parallelize this in R such that you can take maybe the first L apply will take 1 to 1,000, whereas another one will take 1,001 to maybe 2,000 and so forth. So there's parallel version of some of these called parallel apply and so forth. So you can read about some of these things later on. But I will take the first three and show you how this can be used. Okay. So to do this, let me assume that I want to create a matrix now, and this matrix, let's say I have observations from, let's say, 4 students, right? I ask them of the courses they are taking. Let's assume they are master students, so they are taking some maybe actuarial science courses at the master's level. Okay, so I asked, let's say, the first student called Amma, and Amma gave me her marks. Okay, so maybe up to 601, Amma got 76 in the exam. Okay, then I asked, what about up to 603? Okay, so Amma says, I got that one, I didn't do so well, so I got 64. And then I asked up to 605, maybe 71, and then up to 609, maybe 81. Okay, so I can add on to it, and then maybe up to 611. Okay, so 611, maybe 56. Okay, so then I asked another person, maybe Kwesi is also in the class, and Kwesi's own, I'm just going to sample observations. Okay, from 0 to 100, and then I select a size of what? 5. Okay. All right. Now, for let's say Kwame is also a student, and for Kwame's, I'm going to round, and I'm going to select observations from the uniform distribution. Okay, from n is 5, and then minimum is 0, and then maximum is also 100. Okay, so you see what I'm doing? I'm still trying to, so that we can do this by also sampling from other places. Okay, and then let me say I have Obed. Obed is also in this class, and here I want another distribution, right? So I may want to simulate observation from the normal distribution. Okay, so I'll use our norm. Okay, so our norm, how many? I want 5. So 5, so n is equal to 5. The mean, maybe I want it to be around 60. Standard deviation, maybe 5. Okay, so I'll say our norm, n is equal to 5. Okay, mean is equal to, let's say, 60. And then SD, I'll say 5. Okay. All right. And I'm rounding them. Otherwise, I'm going to get decimal places, maybe 6 of them. I don't like that. Okay. So let's assume I have this. Okay. And if I go to my environment, I'm going to see all this shown over there. Okay. So I have let me take this off. Okay. Yeah, so I have Kwesi, right? Obed, Kwame, okay, and then Ama. Okay, right. Okay, so I want to create a matrix now. So create a matrix. Okay, and to create this matrix, maybe I call them marks, right? And I can, because these are observations, I'm going to use row bind, right? So I'll call Ama. You should know by now why I'm not using C bind, okay? Because these are the observations, and the cursors will be the variables. So when we finish, we are going to call the cursors, okay? So I do this. And then now if I display my marks, I have them like this. However, I don't know the cursors that, so I'll name them, call names, so that I name what? The columns, okay? So the first one, let me see, let's say up to 601. Next one, maybe up to 603. So these are all first semester results. Of course, you don't know your second semester results now. So up to 605. And then up to 609. They are 5, right? So I need one more. And then up to 611. Okay. So there it is, 5 of them. So let me run it. And now I display my observations like this. Okay. So this is more or less like a contingency table, right? So now what I want to do is this. Assuming I ask you to find the average marks for the students, then it means you need to, or let's say summary statistics concerning the students, right? Then it means you add all their marks. You will get the average, the median for each of them, and so forth. So that you mean you are dealing with rows, right? So I'll now start with the apply statement. Okay, so I want to find. So my question is find the summary statistics. And as we are doing this, I'm talking about basic statistics as well. So when we get there, find summary statistics for each student. Okay, so that's part of our summary statistics or descriptive statistics. Okay, so to do this, I want to check the apply statement, how this will help us. Okay, okay, so I want the help files so that I'll use it to explain to you. Okay. Now, so the apply statement it's a function over an array margins, right? And it returns a vector or an array. Okay, so basically you have apply, margin, fun, and then you can get other statements or arguments to this function. But X here is an array or including a matrix. Okay, so array or like including a matrix. So data frame is also part of an array, and so you can use it. The margin takes on two values. When it is 1, it means you are dealing with rows. Okay, so when it is 2, it means you are dealing with columns. Okay, so it's up to you to indicate which one you want to use, and please be specific. Okay, then the fun is a function. We've just talked about functions. Okay, so I can write any function, and then I can let this function take in arguments, which is a vector, which are the rows of my matrix. Okay, so let's see. I said summary statistics, so I will say apply, and then I call my X. What is X? X here is marks, right? Which is my marks. Okay. Now my margin is now equal to 1. Okay, and then my fun. Okay, I can say it is equal to summary, because summary is also an inbuilt function. Okay, however, if I were to write my own summary statistics as a function, then it means I must go back to our discussion on functions and get that. But I won't let us do this again so that you know how the uniform this should be. Okay, so if I run this, these are my results. Okay, so our results looks like this, and we can take each student marks and describe it because we have summary statistics. So first of all, we look at Amma. Amma obtained a minimum mark of 56. The first quarter is 64. What is the first quarter? It is what? If we arrange the marks in terms in order, okay, so from the minimum to the maximum, and then the 64 will be in the first quarter, which is that with the division of the values into 4 equal parts. That is the first part, right? So the first quarter, which is 64, and then the second quarter, which is 71, which is of course the median, and then the third quarter is 76, maximum is what? 81. So the first quarter, what it means is that it divides the data into 2 parts. 1/4 of the data set will be less than the first quarter, and 3/4 of the data set will be above the first quarter. Okay. Now, similarly, if you take the median will divide the data into 2 equal parts. Okay, so that is the second quarter. Half of the data below it, half of the data above it. And then then the third quarter will be that it will divide the data into 4 equal parts. the 3/4 of the data set will be below it, and then 1/4 will be what above the third quarter. Now, so what is the distribution? Well, when we want to describe the distribution like this, we will just look at the magnitude of the mean and the median. Okay, so in this case, what we know is that the mean is less than the median. Okay, when the mean is less than the median, what you should note is that the mean is affected by extreme values. So if it is less than the median, then it means I must have some smaller values that is pulling the mean away from the median. Okay, so those smaller values won't have enough or frequency, in other words, the repetitions, compared to those that will be that are close to each other, the values that are close to each other. So what we can say is that if the mean is less than the median, then it means you have more people scoring high marks, and then a few lower marks are pulling the mean towards this away from the median and to the left. So we say that this is what left skewed, okay, or skewed to the left, and or we also refer to as negatively skewed. Okay, so if I should repeat it again, the mean is affected by the extreme values or large or very small values. So if the mean is less than the median, then it means we have smaller values that are pulling the mean away from the median. So in that case, your distribution will have it tilts towards the left, and that is why we say it is left skewed or negatively skewed. Okay. So that's Hamer's distribution, the distribution of the marks for Hamer. Similarly, we can check Kwesi's own. Kwesi's own, we can say it is what? Positively skewed. Why is it positively skewed? Because the mean is larger than the median, which means there are more larger values, right? Sorry, which means there are some large values, not more, but which are pulling what? The mean away from the median. Okay, so in this case, you will have it to be positively skewed. In other words, Kwesi's marks were, more of it were below what the mean than above it, and so forth. So that is positively skewed. And I think with these two, you should be able to interpret that of Kwame and then that of Obed. Okay. What if we were interested in summary statistics for each of the courses? We want to compare the courses. So summary statistics for each course. Okay. Now the course or each subject, you see it will be the same thing, but now our margin will be 2 because we are dealing with what? The columns, right? So 2. And if I do this, you see, now you are dealing with the courses, and you can see which course, you can talk about which course students perform well and which one they fail. Okay. Looking at it, I think if you look at it, up to 603 is not, it's probably the one that they don't have much, the performance is quite low. Okay, we can look at this from a box plot point of view. Remember, we did a box plot. Okay, so I can also give a box plot. Okay, so here I will say box plot. Okay, so it means it's going to plot each of them. Okay, there we go. But we're going to get 1, 2, 3, 4, 5. Okay, so you see each of them, it has given a plot of it. But of course, for us to compare this, we want to get all of them on one on one graph so that you will be able to compare all of them. Okay. So what is happening here is quite easy, and it is easy because we know the functions are inbuilt and it takes in only one argument. Okay. However, if we can, the general form is that, for example, I can say my fun1 is assigned function, so x, and then I'll say take in box plot x. Okay. Sorry, box plot I did not. Okay. So here, because I'm writing my own function, I can even do two of them. Okay. So I may want the summary statistics of x, and then when you finish, I can also say plot or box plot x. So you see, I have now written my own function, and I can call this function to compute these items for me. Okay. So here, if I call this function, I'm going to give the function name what? fun1. Okay. Like this. Okay. And if I run this, you see, but what do I okay, so you get your result, but it's messy, because it takes each of them, and yeah, so if you look at the first one is 601, it's the same thing you got for the summary statistics, but it does plot it as well. Okay. If I want to get rid of all this, I will I can modify this to make sure that I get my box plot, and then I'll say return, and then I say summary of x. Okay, so fun1, and now sorry, let me do this well. Okay, yeah, now it's better. I apply this there. Okay, so if I want to get it this way, so if you want to see what is happening, I can just take out everything, and even I can color. True. Okay, so let me run this again and do it. Okay, there it is. So you see it now. You understand that it plots each of them, and then also give me the summary statistics. So you can write your own function and put it within an apply function. So that's the apply statement. I'm going to quickly talk about the S apply and L apply, and then so the S apply can also be used. However, the way it works is different from the apply. You can look at the help functions, but I'm going to go through it straight away. Now, for the S apply, you need an index, and the index will run through it. So, for example, I want to do the same thing using the S apply. What I'm going to do now is that in my S apply, I'll need an X, and then the function, you can simplify it and what have you. So and so forth. So by default, it's a vector. So I'll say 1 to, because I'm dealing with columns, I'll say n core of what? My marks, right? Marks. So what do I mean by this? This means I have an X, which is 1, 2, 3 up to 5. Okay. So I can say X 1, 2, 3 up to 5. Okay. Now, then I need my function, or the fun. Let me put it, fun is equal to I can say a function. Okay. I can call my function my fun1, right? Like that. Okay. But what I'm going to do is that because um, fun1, right, is a function that takes in x, I want to take in each of these columns. So I'm going to do here, sorry, I need function here. Okay. And my function should take in like an argument I. And I is actually the index. Okay. So I'll say I like that. Okay. So what it means is that take x will take 1. I pass 1 to my function, which is I. And then so I have 1 here. It goes to max 1, which will be the first column. Compute what? Your box plot and also the summary statistics and so forth. So let me just clear my graph area, and then you see that whatever we are doing is actually correct. So you see I got the same thing, okay, but now it is not named, okay, and so forth. So you can actually use the s apply to get some of these things. Now the difference between the s apply and the l apply is simple. The l apply can be used also on list and so forth, but I can use it to do the same thing, the same work. However, my results will be a list. You see this one I got, S apply can give you a result that is a matrix, or that may be a vector, but for L apply is going to give you a list. Okay, so just the L apply only changes, and I'm going to get my plot. I can take this one out. I'm going to get a plot. Okay, but you see my results is now a list. So I have the first one minimum, the second one, third one, fourth, and fifth. Okay, so that's how this L apply, S apply can be used. Okay, in getting yeah.